What's up, guys? Very, very sorry I wasn't there today and had to leave early yesterday. I I finally did succumb to the stomach bug that's been passed around the house, so hopefully that's the end of it, and I should be there tomorrow. But I know today we were supposed to go over some questions, get you ready for the CA and review for that. So I wanted to kind of do that now so that you can look over some things and get an idea of what type of questions might be on there. So anyway, the first thing I'm going to do is the district did give me kind of an outline as far as the topics of each question and how many from each topic. So there's going to be 25 questions altogether. There's going to be, and like I said, it's all ecology. There's not going to be anything about evolution. So there's going to be 5 questions on like relationships among organisms. So like parasitism, predation, commensalism, mutualism, competition. So as long as you remember what all those are, that's 5 questions right there. That's 5 out of the 25. So predation, parasitism, commensalism, mutualism, and competition. So all those different, like I said, kind of relationships between organisms. That's going to be five of the questions there. And like I said, we'll go over some questions here, but I just wanted to kind of give you the outline so you can look over if you have your notes and such. The second biggest chunk of it, another 5 questions, is going to be from the topic of the flow of matter and energy through different trophic levels using various models. So basically, like food chains, food webs, looking at pyramids. So basically, interpreting, how much energy is left at each trophic level, and if you get rid of this part of a food web, how does it affect the other parts of the food web? Energy being lost as heat during, while it's passed on to trophic levels. So those kinds of questions. So there's 10 total questions right there on, to me, I think, a pretty easy part of ecology. At least I think most of us did pretty well on those types of questions on the test. Then there's going to be 4 questions on the topic of how environmental change can impact ecosystem stability. So basically, like if humans come in and change an ecosystem, how does that affect the stability? And like I said, we'll go over some questions to give you some examples. Then there's going to be 3 questions on the cycles, so like the carbon cycle and the nitrogen cycle. And then 2 questions on the role of microorganisms, so like bacteria, so like the role of bacteria in maintaining the health of ecosystems. 2 questions from how variations and adaptations of organisms and how they kind of look in different ecosystems. So like what type of adaptations might an organism need to live in the tundra, or what kind of adaptations an organism might need to live in a certain environment. Then 2 questions from the long-term survival of species is dependent on changing resource bases that are limited. Again, we'll go over some questions. And then the last 2 questions would be how organisms, populations, and communities respond to external factors. So that is the 25 questions, the topics of all the 25 questions. So let's go ahead and we'll start with there's only going to be a couple questions on this one, but it's investigate and analyze how organisms, populations, and communities respond to external factors. So the question states, it has a picture of a plant here. Okay, and you can see on one side the plant looks healthy, on the other side somebody's touching the plant and it looks all wilted. And the question says the mimosa plant displays thigmotropism, which just means it responds to touch by collapsing its leaves in response to touch, as shown in the picture below. The plant on the left side is undisturbed. The upper stem of the plant on the right side has been touched. What's the most likely benefit of this mechanism for the plant? Is it A, protection from a loss of minerals to the environment? B, protection from poor light availability? C, protection from herbivores by becoming less attractive? Or D, protection from overwatering? So obviously that one's going to be C. It wants to look like it's wilty, look like it would taste nasty. So C would be your answer there. Now we're going to look at some from the topic of the role of microorganisms in an environment and how they kind of keep an environment healthy. One of these questions we went over before. We talked about in one of the warm-ups how it says a student set up a compost bin outside. Inside the bin, microorganisms convert the student's vegetable and paper scraps into rich fertilizer. Which of the following best describes the role that these microorganisms play in natural habitats? And if you recall, the correct answer was G. The microorganisms help keep nutrients cycling through the ecosystem. So they help to, recycle the nutrients. Another question that would be from this topic that you might see is some fungi secrete substances that are toxic to bacteria. That's a key part right there. If it's toxic to bacteria, then it's probably an antibiotic, okay? That compete with them for food. So scientists have used their knowledge of this ability of fungi in order to produce which of the following substances? Again, antibiotics would be your answer there. That's your examples of, again, summarize the role of microorganisms in maintaining and disrupting the health of organisms and ecosystems. So now we're going to go on to, let's see here, 12A, yeah, there we go. So now we're going to look at the relationships one with you're looking at predation, parasitism, commensalism, all that stuff, okay? Again, these were ones I think y'all did really pretty good at. Basically, you just have to interpret. They'll give you a paragraph, and you have to interpret, is it talking about, is the situation commensalism, is the situation parasitism, predation? You just have to interpret the situation. So here's an example. It says, parrotfish are herbivores that are found in coral reefs. To escape predation, a parrotfish will graze with a rabbitfish, which has venomous spines at the end of its pelvic fins. The rabbitfish does not benefit from the relationship. Which type of relationship do the parrotfish and the rabbitfish have in the coral reef environment? So again, one is being helped. The other one, it told you it's not affected. So that's going to be commensalism. Okay, and the way they have it, it's a commensal. Don't get confused. Commensal and commensalism would mean the same thing. So it's a commensal type of relationship. Okay. Another example is it's the same exact kind of question, except they give you a chart. Well, the chart says X, Y, and Z, and X has a certain situation, Y has a certain situation, and Z has a certain situation. And you just have to interpret the situations and then kind of put them in order as far as which one is commensalism, which one's parasitism. Okay, so it says barnacles adhere to the skin of a whale in order to be deposited in a new location. The whale does not appear to be affected. So X right there would be commensalism. Y says fleas attached to the skin of warm-blooded animals feed on their blood and make the animals itch. That's obviously parasite. And then Z, fungal mycorrhizae live on plant roots and increase the plant's ability to absorb nutrients. The mycorrhizae are provided with carbohydrates from the plant. So that one, they're both benefiting, so mutualism. Okay. Another one talks about a fungus that attaches to the face of a bat and like almost 100% of the time kills them. So the fungus in the bat, that would obviously, the fungus would be a parasite to the bat. It's a long story though, so I wasn't going to read all of it, but just know if you see one that has to do with bats and fungus, it's talking about parasites. This one I believe was on our test. I think this one was on our test about dispersing the seeds. Okay. The little agouti or whatever, the little ground squirrel looking thing. How does it help the ecosystem? By eating and then dispersing the tree seeds. So the answer would be F on that one. Another one, I know we talked about this one in class with the ant and the acacia plant. Okay, remember the ant, I think, stings different animals that come and try and eat on the plant, and the plant gives the ant a home. So that would be mutualism. They're both helping each other out. Another example here, it says a native species and a non-native species are competing for resources within the same ecosystem. The non-native species is more likely to survive than the native species in which of the following situations? The answer here, and this is another one I think we did in class together, the non-native species has no natural enemies in the ecosystem. And that's a lot like we talked about in class. With an invasive species, they don't have any predators, they don't have anything that's going to take them out in the ecosystem. So a lot of times they'll do really well. All right, the next one I want to talk about, the topic's going to be compare variations and adaptations of organisms in different ecosystems. So the question I wanted to show you is this one. It's about rhinoceros. So there's a chart, and I know it's backwards, but just go with me. So there's a chart here, and it describes kind of how these different rhinoceroses feed. Okay, so it says here which rhinoceros species is best adapted for feeding in the large open grasslands of African Serengeti ecosystem. So basically, you just got to look for the one that would eat on small grasses, low-lying, short grass. And your answer here would be B, the white rhinoceros. So that was the topic. There's only going to be 2 questions. So that's really the only sample I have for you. This one is one that's going to have 5 questions, and it's analyze the flow of matter and energy through the trophic levels. So this is one about food chains, food webs, things like that. First question here, which of these organisms are in a trophic level that receives a larger percentage of the energy captured by the producers than the percentage received at the bat's trophic level? So it shows you this big, huge food web, and you have to see, okay, which organism that they list in the answers would get more energy from producers than the bat. Well, basically you're just looking for any organism that's lower on the trophic level than the bat is. And when you look, it says mountain lions. Well, mountain lions are actually higher than bats. It says snakes. Snakes are on about the same level as the bats. It says hawks. Again, hawks are higher up than the bats. And then the only one that makes sense would be the ground squirrels. The ground squirrels are right above the producers, so they'd be getting more energy from the producer than the bat would. Okay, remember the 10% rule. Another one talks about a student's asked to draw a food web in which the same organism is a primary consumer as well as a secondary consumer. So how should the organism be represented in the food web? So if you're looking for, it's a primary consumer and a secondary consumer, okay, it's going to have an arrow pointing to it from a producer, but then also an arrow pointing to it from a primary consumer. Okay, that would be H on that one. The next one, it shows you a food pyramid, and it has those arrows going out, okay, going away, and it wants to know what X means, and that would be heat. But remember, as you go up the trophic levels, you're going to lose energy as heat. Okay. A lot of them just interpreting food webs. Which of the following lists only organisms that are secondary consumers in the food web? So you just have to be able to interpret the arrows and see which ones would be secondary consumers. Your answer there would be H, spiders, foxes, owls, hawks, and snakes. Another one, which of the following are missing from the food web shown above? I think I showed you all this one. Remember, it doesn't have any decomposers. So if it doesn't have an arrow going back down, then there's no decomposers. Let's see here. That's really it for those. The next one is where there's only going to be 2 questions from this topics. It's recognizing that the long-term survival of species is dependent on changing resources bases that are limited. So the question says, in recent years, humans have interfered with the natural balance within deer populations in various ecosystems. The interference includes eliminating predators of the deer. Which of the following statements correctly describes the long-term outcome of this interference? So the answers are the deer that are the fastest and most agile will survive and reproduce. The deer population will be too large to be supported by producers. Other browsing species will thrive and outcompete the deer, or the producers will evolve into species that are less palatable to the deer. Your answer there is going to be G, which is the second choice. The deer population will be too large to be supported by the producers. So if there's no natural predators for the deer, they're just going to keep growing and growing and growing, go past that carrying capacity, and then it's not going to be good. The next part is going to be about 3 questions, and it's about the carbon cycle and the nitrogen cycle. Here's a little graphic there, and it shows some different things going on in the carbon cycle. And it asks basically what is represented by the letters X and Y, and it's basically the arrows. So you can see X is always something like dying and going into the bacteria, so that's obviously going to be decomposition. And then the other one is something like breathing out, which we said that's a big source of how carbon dioxide gets into the atmosphere. And so Y would be represented by respiration. So X, decomposition, Y, respiration. The answer there is J. Another one about the cycles is the exact one down here that we talked about in class, about what happened, how would more carbon get into the atmosphere. And we said that it would be A, the destruction of terrestrial biota. Because terrestrial biota is on that carbon reservoir side, and if you get rid of a carbon reservoir, obviously that's going to put more carbon into the atmosphere. The other one here is something about a fish tank, and how could you keep nitrogen cycling through the fish tank. It has a little picture of a fish, and I don't want to show you, it's kind of a tough thing to see. But basically it's asking what could you add to the aquarium to remove the nitrates. Okay, well remember plants can do that. So if you add more plants, that would be a good thing. The next one has 4 questions from it, and that's describe how environmental change can impact ecosystem stability. This one has a chart about pink salmon and how an oil spill affected them, and you basically just have to look at the population size, and really you see that the pink salmon really were minimally affected. They weren't really affected at all. You can see how, there's the chart, and the pink salmon kind of varies year by year, but when the oil spill happened, it didn't really affect them. Another one says dead zones are low oxygen areas that develop on the seafloor. Scientists hypothesize that phytoplankton blooms cause these dead zones. Phytoplankton blooms occur when excess nutrients are introduced by pollution from fertilizers, sewage plants, and the burning of fossil fuels. Which of the following would most likely cause an increase in these contributors to dead zones? And your answer there is F. Rainfall patterns that increase freshwater runoff from terrestrial ecosystems. So if you're getting more runoff from farms and places that use fertilizers, that's going to obviously increase the amount of phytoplankton there. This one says, in dry desert areas, poor drainage can lead to buildup of salt and water supplies. A student performed an investigation to study the effects of salinity on the germination rates of seeds. The student placed seeds in several solutions containing 0% to 3% salt. The length of the radicle, which is the root of the germinating seed, ranged from 49 millimeters in the 0% salt solution to 0 millimeters in the 3% salt solution. The data from this investigation suggests that increased salinity in more areas may lead to a decrease in which of the following. And your answer is going to be, is it air pollution, food production, oceanic evaporation, or non-renewable resources? Basically, the only thing that makes sense would be food production, because the test was on plants, which is food. So food production would be your answer there. Another one, the overgrowth of algae poses a major problem for coral reefs. Intensive fishing is one factor that contributes to algae overgrowth because it does which of the following? Is it A, allows more sunlight to be available to algae, B, inhibits the spread of pathogens in algae colonies, C, reduces the number of organisms that feed on the algae, or D, increases the competition between different algae species? It's going to be C. If you're taking out fish that eat the algae, again, common sense. So C, reduces the number of organisms that feed on algae. I think that's really about it. I think we covered all the different topics. Yeah. I should be there at my normal time around 7:45, 7:50. So if you have any questions or you want to go over some more stuff together, I'd be happy to. Again, I'm really, really sorry that I've been out so much lately with sick kids and now me getting sick. There's just nothing I can do about it. So hopefully we're past that and we'll be good to go for a long time now. So anyway, enjoy the rest of your evening. Sorry this was so long, but we would have probably spent 20 minutes in class doing this. So have a great rest of your night. I will see y'all tomorrow for Friday Eve.